So welcome YouTube, beautiful mind here. Welcome students, Professor Pfeiffer here, aka Professor Pfeiffer. Let me see, before I open the floor for questions, let me see if there are any announcements. I don't really have any major announcements on my end. The main thing is that you're making your way through the assignments, okay, on a consistent, steady basis. Be aware that we get unlimited attempts at all assignments, and you can actually submit assignments late with a 10% late penalty. Um, so like even if you submit it late and you want an 8, it just has to be a perfect score. That's on everything, homework, quizzes, and exams. I do monitor the chat, and feel free to unmute yourself if you have questions or if anything is not clear. Otherwise, I'm going to just kind of hop into the assignment and kind of keep going with what we need to talk about. Okay. So let me see. I know I made a video for section 1.7. Maybe it was yesterday. So there is a lecture for this. You know, I try to get the lectures up before I do the homework as early as I can. So the chain rule is the next differentiation technique that we want to explore. And the main thing, let me see, who is this? First and last names would be nice, because when it's just the first name, then I have to like search through. Okay, the main thing with the chain rule, the technique for chain rule basically is like the derivative of the outside function times the derivative of the inside function. That's the main thing with the chain rule. So let's see if we can see this in action, and let's keep it going. Okay. Yeah, I'm gonna let that be for now. Okay, so I think this is a augmented review, or this is kind of a review question. Let f of x be this, g of x is this, and h of x is this. Write n of x as a composition of the functions. Okay, well, it looks like we don't need f. We want x minus 4. Okay, if we did g of g, like g inside of itself, then we would have x minus 2 minus 2, and that would give us the x minus 4. So I was thinking this one. That comes from college algebra. So composition, this little circle here. All right, I'm letting students in as they arrive. You guys are doing pretty good with attendance, actually. The time. So yeah, let me just make this disclaimer for anybody that might be new. The way I decided to do the class this semester was asynchronous. My only request is that you basically check in at the start of each class. Like, you don't have to stay, just check in, get your attendance credit. If you need to keep moving, it's totally okay. You guys are, I mean, you're upperclassmen. You seem to be a little bit more responsible in that sense. So yeah, because I know the challenge of being online at a certain time, and the main thing is as long as you're in communication, that's the main thing with me. Don't just be MIA and then materialize at the very last minute. But it's, you know, you guys have been pretty good, so I'm just saying it as a disclaimer. So this symbol, to kind of recap from college algebra, this is called composition or composite. G compose F, right? So it's an open circle. What it means is the second function inside the first function. Here it is. Okay, cool beans. So yeah, that's just from college algebra. I'm gonna let that be and not dwell on that too much. So let F be this and H is this. They're asked us to find F of H of 3. Okay, I'm gonna write this one out. Ooh, I gotta chill. Okay. So let me take some notes before I hop over to the tablet. Again, this is kind of a review for right now. We still have yet to get into the chain rule, which is the topic for today. The chain rule, and I think the second part is higher order derivatives. So I'll try to watch the clock. I know we run from about 6:35. I want to be switching gears. Let me see. Hey Siri, set a timer for 30 minutes.
Okay, 30 minutes and counting.
Thank you, Siri. All right, so let me take some notes. Then I'll hop over to the tablet. So this is question. These questions come from section 1.7, the chain rule. Okay. This is question number 2 from this assignment, and this is I think it's augmented review or AR. Section 8, question 18. All right, so it's a review section. We're given that f of x is 2x minus 1. Okay. H of x is this x plus 5. Oop, that's not a 5. Over 3. And then we're asked to find f of h of 3. Okay. All right, let's hop over to the tablet. Let me see if this technique works. It was working last time. That's looking good. I'm gonna let that be. All right. So we're asked. So this is a review from college algebra, right? We're asked to find f of h of 3. Okay. So let's see. Let's start here. We have this f compose h of 3. This means f of, when you think of h, what color comes to mind when you think of h? Like yellow? I think yellow for some reason, but I'm not going to use yellow. I'm going to use orange. So this means f of h of 3, right? So basically the second function inside the first function. So I'm going to go ahead and find h of 3 first by itself, and then take that answer and plug it into f. So if we do h of 3 off to the side, that's going to be 3 plus 5 over 3. It's going to be 8 over 3. Okay. I'm going to take this and plug it in to f. So then f of 8 over 3, I might need my calculator. Let me see. That's going to be 2 times x minus 1, but the x in this case is this 8 over 3. Okay, we're okay. That's going to be 16 over 3 minus 3 over 3, which is 13 over 3. Okay, so this was the final result we got there. So this is just kind of a review of composite functions, or functions within functions from college algebra. Okay, so we got this. Let's hop over to Pearson. Let's see how do we do. Integer or a fraction, 13 over 3. God is good, okay? All right, on to the next one. Use this function below for the parts. First, we're asked to graph. Okay, so notice the highest degree is 2. This is a square function, so it should be a U-shaped graph, right? So notice the leading coefficient is positive, so it can't be A or B, because they both open down. Ours opens up. Notice we're multiplying by a number larger than 1 on the outside, so that should cause a vertical stretch. It should get bigger in the y sense, but stretch vertically. So it should become tall and narrow. So I'm going to go with D. I'm going to go with D. Okay. Then draw lines tangent to the graph, whose x-coordinates are 0, 1, and 4. I think we can just match up the graphs. It can't be A or B. Are they the same? Okay. So it looks like C and D are similar. Let me see if I can make this view a little bit better. I think if I go like this, I don't know if that's better, but who is this? Okay, cool beans. Yeah, you guys are pretty decent on getting into class. Let's see, when x is 0, 1, and 4. Okay, so we just need to decide which one of these is correct. X is 0, 1. Let's look at this one. This one looks wrong. Let's look at it. 0 when x is 1. X is 4 is over here, right? So it's missing x is 4, so it should not be that one. Let's do this one. Let's look at D. When x is 0, that's a tangent line. Notice how it touches the graph at one point in this fashion. It's not cutting the graph. It's a tangent line is going to touch the graph at one point in this fashion. It's going to like gradually get close, touch at the point, and then gradually start moving away. This is also a tangent line. X is 1, that purple one. And then the green, tangent line when x is 4. I'm going to go with D. All right, D looks good. Okay, it can't be A and B because they open the wrong way. Okay, now we're asked to find, it says find f prime by doing the limit quotient definition. For your purpose, you know, it would be good practice. You don't have to do this. If you wanted to use a shortcut, you bring the exponent down and then subtract 1 from the exponent, you should already get the answer just like that, right? If you bring the exponent down and subtract 1, it's just going to be 7x, right? So if we do this difference quotient, the limit as h goes to 0 of the difference quotient, we should get a result of 7x. So let's do it. Let's do it, right? Just to see, to test ourselves. Okay, attendance is looking good. Admit. And feel free to either unmute yourself or type in the chat. I do monitor the chat. But feel free to unmute yourself. Oh, I think there is something in the chat. Let me check the chat. I gotta figure out. Just try to remind me towards the end of class about the email. I'm pretty sure I did get it, and I get behind on emails very easy. So if I don't respond to your email by the time we get in class, just ask me during class. Like ask me towards the end of class. That's the best because once I'm not here with you guys like this, I'm off living my life. It's like I have a hard time. So, but just if you can get my attention, like either unmute yourself or whatever. I think my audio is working. So, um, ask me towards the end of class about your email. Okay. Let me do this real quick. Let's undo this. Oh, all of this stuff got changed. We're gonna do this one. We're gonna do this one. That one should be fine. That's fine. Yep. Yeah. All of this is fine with me. Okay. Okay. So we're anticipating the result here to be 7x. So then let's do the limit definition of the derivative and see if we can get that result. Okay, just taking attendance. All right, so let me take some notes. So this is question number 3. This comes from section 1.4, question number 1. Let me make this a little bit better. Okay, that looks good. We're given that f of x equals, we got this 7 by 2 times x squared. We did a and b, so then c, that's not a c. C asks us to find f prime. I'm going to say find f prime of x using the limit as h goes to 0, as some change goes to 0, of f of x plus h minus f of x all over h, right? So they want us to find a derivative using the limit definition of the difference quotient, the limit of the difference quotient definition. Attendance, that looks good. Admit. Okay. Okay, we're about to do that. And then part D, let me just go ahead and write this. Everybody's like, and like another reason I'm being kind of lax, because I know I like changed things last time. I had to send out an email. And like, I think one of the students here suggested, we have Zoom. And so I looked into it, and sure enough, it was the full version. So we can kind of keep clicking. Part D, I'm still trying to take my notes, says find f prime of 0, f prime of 1. So once we find f of x, these will be easy. F prime of 4, okay? All right, I think we're done with the notes. Let me hop over to the tablet. Let's look at this. Limits like this cover. This comes from section 1.4. So section 1.4. The part in the book is in the upper left-hand corner. That's 1.4.1. That tells you that it comes from section 1.4. That comes from section 1.4, question number 1 from the back of that section. Let's hop over to the tablet like this, and we should be good to go. Okay. All right. I mean, I guess I could do the desktop. That might be a little bit easier. But I don't like, the reason I don't do the desktop, because sometimes I have things pop up that are sensitive that I just don't want streaming. So I'm going to just keep doing what I'm doing. Okay, so for part C, let's do this difference quotient. So before I go into all the parts of the difference quotient, I want to isolate the f of x plus h, right? I just want to do that by itself. F of x plus h. Okay. So that's going to be 7 by 2. X plus h is going to go there. And again, we're plugging in x plus h. Okay. So then let's expand that out. That's going to be 7 by 2 times, that's going to be an x squared plus 2xh plus h squared, right? So then ultimately that's going to be 7 by 2x squared plus 7xh plus 7 by 2h squared, okay? So that's f of x plus h. Now I think we're ready for the limit definition. We got the limit as h goes to 0 of basically what we just found. Okay, minus f of x, which is 7 by 2x squared. So we didn't need to distribute a negative or anything there, but it still is there, all over h, right? Notice this guy cancels this guy, right? Notice the remaining terms all have h, so we're going to factor out an h from those guys. Let me highlight those h's, right? So again, if we factor out an h from those, we're going to have the limit as h goes to 0. There's going to be an h out in front, and this leaves us with 7x plus h squared all over h. Now, this h cancels this one, right? And now we're ready to take the limit. We got a student, L, JK. There he is. Cool beans, cool beans. You guys are doing awesome. Just showing up is like the biggest part of the challenge. But we are good. Let me say this: you guys are doing pretty good with attendance. But if I notice that like students are coming in past the 15-minute mark, what I'll probably start doing, like when I do that first wave of attendance at the start of class, that's full credit. And then after I've done that first wave, if you show up between the start of class and the first 15 minutes, that's considered late. After 15 minutes, I'll probably let you in, but I won't give you attendance credit. I don't really see that being an issue with this class. You guys have been pretty good. Again, this is asynchronous. All I really need you to do is check in, and if it's, if you need to step away, it's totally okay. Just check in with each class, but you don't have to stay. But I'm just saying that as a disclaimer. You guys are actually doing pretty good with attendance. So let's keep going. Okay. So let me see. I think the chat looks good. Okay. So now we can actually take the limit as h goes to 0. So as we take the limit as h goes to 0, this guy is going to go to 0, and the other one persists. So then this is just going to be equal to 7x, which is what we anticipated, right? So that was the derivative that we were anticipating. Okay. I think we can hop back to Pearson. I think we have more than enough to answer the questions. I'm going to hop back over to Pearson. So then the derivative that we got 7x. And again, you didn't have to do the whole limit definition. I think it makes great practice. But remember, the shortcuts, we could just look at it. The 2 comes down, they're going to cancel, and 2 minus 1 is 1, and the final result should be 7x. Let me finish this out, then I entertain questions. I saw the chat. Select the correct choice. Oh, f prime. So when x is 0, now that we have the derivative, when x is 0, we're going to get a 0 for that one. Come on, computer. When x is 1, it's going to be 7, because 7 times 1. Like, once you have the derivative of these, the rest of these are quick. And then when x is 4, the result should be 28. Okay, I think, and that'll be it there. Let me check the chat. Okay. How do we know when you take attendance? Oh, so if you get, once you get into my my Zoom call, I take attendance as I let you in. So once you get onto the Zoom call, I give you attendance credit. So far, I haven't really been doing that whole late thing. People have been showing up, they've been doing what I asked, so I haven't been making a big deal. So yeah, as long as you get into my Zoom, that means you got attendance credit. I don't let you in if I don't see your name. Okay. Yeah, that's how it goes. It's not really factored into the grade. It's just for records. It does come into play like if you accumulate too many absences. Like once you hit that 4th absence, then it can kind of affect your money. You can be automatically kicked out of the class. I just need you to show up. Once you see your name in the Zoom list, because I take attendance as a last student in, so I think you're okay with that. Let's go on to the next question. Hopefully that answered the question with all the pertinent parts. Ooh, it says 11:11 in the upper right hand corner. That's awesome. That's a good omen. Okay, let me see, graph. Okay, this is kind of a repeat. Let me see my time. I kind of want to go on to the next one. Yeah, let me try to jump ahead some because we don't have a lot of time. I don't want to do a whole bunch of repeats. Let's jump to question number 13. Let's see. Oh, and also if you all request, if you want me to like go through one, yeah, everything is unlimited attempts. Homework, quizzes, and the exams. You can definitely take advantage of that. Everything is unlimited attempts. But past the deadline, past the due date, there's a 10% late penalty. But the grade is set to take whatever your highest score was, right? Differentiate the given. Okay, this is chain rule. I want to get to the first one that does chain rule though. Let me go back some and try to find a better one to start off the topic with. Let me try 7. That one is good. I like 7. Let me try 6. I just want to see if 6 is better. 6 is that 6 comes from section 1.4. That's the quotient rule. Low D high minus high D low over low low. I'm not going to do that one right now. That's actually 1.4 is the power rule. In this context, it is similar to the chain rule, but I'm not going to do that one right now either. Here's the first one for this section. Let's start here. This is a good one to get into the topic with. So we're asked to differentiate. So the chain rule basically is the derivative of the outside function times the derivative of the inside function, right? And again, derivative. What derivative is telling us is the derivative is telling us the slope of the tangent line at any given x value, right? That's what all of this is about. It's telling us about the slope of the tangent line at any given point. So this question comes from, this is number 8 from this, so I just jumped forward because I wanted to get into the topic. This comes from section 1.7, question 1. We're asked to differentiate, okay? All right, we have, ooh, it's getting chills. Y equals, I'm like, did the AC come on? I'm like, why did it come on? It's not even hot. Y equals 5x minus 14 to the 5th power. Okay. All right, differentiate. Oh, chain rule. So I was taking notes. Let's hop over to the tablet, which is here, and like this. Let me check. Looks good. Testing. That looks good. Is that still playing? It is. I just want it soft. Hopefully that's not too loud. That looks kind of loud. I'm going to turn it down. So I can't hear it, but those bars are kind of high. Anyway. Okay, so differentiate. So we're going to use the chain rule. We have a function within another function. So basically chain rule is the derivative of the outside function times the derivative of the inside function. Let me see one other thing. Not here. Okay, dy by dx. Okay. So the derivative here, our dy by dx. So the derivative of the outside function, the 5 is going to come down. And we're going to subtract 1 from the exponent. So then that's going to be 5 times 5x minus 14 to the power of 4. Then we're going to say times the derivative of the inside function. So the inside function, the derivative there is just going to be 5. Right? Because the derivative of 5x is just 5. The derivative of a constant is 0. Right? So then we can just do a little bit of rearranging and we'll get 25, 5x minus 14 to the 4th power. Okay. Let's go with this. Let's check this in Pearson. Okay. Ooh. Let's see. I'm going to hop over here and it's this way. All right. What's my time looking like? 10 minutes on this section. Okay. Let's see, we got 25 parentheses, we got 5x minus 14, that's not a 4, 14 to the power of 4, okay. Okay, I think the chat is okay, and you should be able to unmute yourself. Let me check the chat. You should be able to unmute yourself if you have questions. Yep, no worries. Yep, cool beans. On to the next question. What's the time? We got 10 minutes. I think we got time for maybe one more. This is kind of a repeat of the previous. Let me try to find one that's a little bit more interesting. That one is cool. This one's, let's do this one. This one's a little bit it's applying several different concepts. So this one looks like the chain rule in conjunction with the product rule, right? So let's take some notes and let's walk through this. This will be the last of this section. Then we're going to hop to section 1.8. Also, I take requests. Also, as you're working through the homework on your own, if you get stuck, make use of the Ask My Instructor tool. If I don't respond to the email before the next class, just bring it up during class sometime, and we can talk about it. Like we don't have to stay on the section that we're on. We can kind of jump around. So this is question number 11. This question comes from section 1.7. It's question number 11 from the back of that section. We're asked to differentiate. Okay. We have y equals 2x minus 4 squared times 1 minus x cubed squared. Okay. Let's hop over to the tablet and so you can see my notes. All right, I think we're good. All right, so the first thing I notice, let's do the product rule, right? So product rule goes the first times the derivative of the second plus the second times the derivative of the first. So let me write that out. So my dy by dx is going to be the first, which is this guy, this 2x minus 4 squared, times the derivative of the second, which is this guy here, plus the second, which is this, times the derivative, or d by dx, of the first. Okay. So again, product rule, first times the derivative of the second, plus the second times the derivative of the first. Let me, because I'm on this device, let me put all this on one line. So I'm just going to kind of shrink some stuff down. I hope everyone enjoyed their Valentine's Day, you know, whatever you intended to do. You're able to, oh, are you guys talking? No? Okay. So I kind of also did something different with my audio. I decided to feed the line instead of play over my speaker. I did go back and listen to one of the presentations, and I was like, the audio was so bad. So I was like, okay, let me feed the audio line into the computer instead of do it through the air. And so I'm still kind of working out the kinks on some of my audio, but it seems like it's working. It took a lot, like it took almost my whole Saturday to get that working, but I got it working. So I was like, okay. Okay, let's take these derivatives. So then this is going to be equal to, so the first is just going to come down. We're still going to have our 2x minus 4 squared. So the derivative there. Now, if we're focused on this guy, that's when we invoke the chain rule. So we say the derivative of the outside function times the derivative of the inside function, right? So what that's going to give us is going to be that 2 is going to come down. Then this 1 minus x cubed persists because then the x is going to be to the power of 1. Then we're going to say times the derivative of the inside function. Okay? So the derivative of 1 is 0. The derivative of negative x to the third is going to be negative 3x squared, right? So we're going to say times negative 3x squared. Okay. All of that is that first term. I'm going to say plus the 1 minus x cubed squared, that just comes down. Now we use the chain rule again. So the 2 comes down, this 2x minus 4 persists, the exponent stays, and then we're going to say times the derivative of the inside function. So the derivative of the inside function in this case is just going to be 2. Because I'm just going to shrink this down onto one line. And then we have a few more steps. I know it's a little bit, to me, this kind of stuff is kind of hard to follow other people's work. I'm really just trying to prime you so that you can take it and make it your own, right? I'm trying to show you that it's possible, and then you have to kind of go take it and make it work for you. Trying to follow what I'm doing can be a challenge, right? But if you get the concept, then you go and practice, you can find your own way. But trying to follow somebody else's work to me that's a task in and of itself. So now let me let me try to rearrange these things. Let's see. I'm going to change some colors here. So we got a 2x minus 4, and there's another 2x minus 4. I'm going to make those blue. So there's one there, and there's one here. So I think we can do something with that, right? Both terms also have this 1 minus x cubed, and on the other side of the plus, there's another 1 minus x cubed, right? So they both have that. So in both terms have the blue and the orange. So I'm going to factor out the blue and the orange from both terms, right? Looks like we can do it 2 as well from both terms. Okay, I'm going to do one other item because it looks like we can factor out a 2 from both terms right there. 3. I'm going to do that one in purple. Okay. So it looks like both terms, again, terms are things that we add and subtract, right? So there's two main terms here. Factors are things that we multiply and divide. So both terms have an orange, a purple, and a blue, if that makes sense, all right? So I'm going to factor out the orange, purple, and blue from each term, okay? So then, it's okay, I can't do anything about that. So then this gives us, all right, my timer is about to go off. 7:15. Okay, this gives us 2 times, we're going to have this 2x minus 4. We're also going to have this 1 minus x cubed. Now what's left over? We still have a 2x minus 4. That's multiplied, so we need to say times negative 3x squared, okay? Is that right? Okay, and that plus needs to persist. We got rid of the blue, purple, and orange. So then what's left in the second term, 1 minus x cubed. One of those is gone. That's gone. And then the 2 persists. Okay, we're almost there. Let me get this on one line because I can. Shrink it down. Basically, I want you here, you here. And then I'm going to expand it back just to fill up the page. Okay. All right, let me check my parentheses. Let's try to bring this on home. So that stuff in front persists. So we got this 2, we got this 2x minus 4, this 1 minus x cubed. I'm just going to leave that be. Now we're just trying to simplify this stuff, the remaining items. So what I want to do here, I want to distribute this guy. Here, I want to distribute the 2, okay? And then I want to combine like terms. So then this is going to give me negative 6x cubed plus 12x squared plus 2 minus 2x cubed, okay? Almost there. 2x minus 4, 1 minus x cubed. Let's see, negative 6 minus 2 is negative 8. 12x squared. It looks like there's another 2 in there that we can factor out. Plus 2. Let me factor out that final 2. We could probably factor out a negative 2, but I'm going to factor out negative 2. If I factor out negative 2, that's going to transform this into negative 4. The 2x minus 4 is there. The 1 minus x cubed is there. And then this becomes, what was that, 2x squared? Wait a minute, that's cubed. That's cubed and that's cubed. 2x cubed minus 6x squared minus 1. Okay. Whew. That thing got me. All right. That was intense. That's what I think the result is. It's time to go into the next section. Let me see if there's anything else. I think that's it. That's about the best that we can do, okay? So, let me put it into Pearson. Let's see how do we do. So let's cross our fingers. All right. Meticulous, being meticulous, taking our time, spacing it out as best we can, being neat as we can, as organized as we can. Let's hop over to Pearson. Let's submit this answer. Before I do that, that seems like it was a bit much. So I'm going to go to the question help and I'm going to click on view an example. And it says 8 parts. So what I'm going to do, I'm just going to kind of hop to the end. I'm going to keep clicking on continue. I just want to kind of get an overview. Now, if I can go back and read it and see all the details if necessary or get ideas, but I just want to compare their technique and the final result they get to what I've gotten before I submit it. So notice they got this long thing. Oh, and they left the negative here, but I think what we did was fine. That's a 5 and a 5. So they like only thing that might be different is I took the negative out. They left the negative in there, but they did get something very similar to what we have. So I'm gonna submit what we have and go with it. Okay. And if it's wrong, I got a quick change that I'm gonna make. I'm gonna put the negative back if it's wrong, but it's the same thing. 2x minus 4 parentheses 1 minus x cubed, and then this final thing. We got this 2x to the power of 3. Did I do that right? Let me see. Minus 6x squared, 6x squared, minus 1. Cross our fingers. All right. So for all I'm going to do right now, I'm going to put the negative back. X cubed. I'm going to put this negative in front. I'm going to put it back where I got it from. And what that does, that makes this negative, that makes this positive. It's not a positive. And that makes this positive. Okay. And if that don't work, then let me see if I can find, I can't think of anything else. Other than that, I'd have to go, oh, I found another factor. So we can factor out a 2 from that 2x minus 4. Okay. There's a 2 here. So let's factor that out. That's going to turn this into an 8. That's going to turn this into a 1 and turn this into a 2. All right, I'm going to go with that. Oh, your answer. Oh, come on. They tripping. The 4. Was that supposed to be 4? 2, let me see. 12, 6. I think it was supposed to be 4. Anyway, we're close enough for me. It was, because the 1 is the same, the 6 is the same. It's this guy right here. We put -2 and it's supposed to be -4. Let me think. And I think I did write 2 and it should have been a 4. That was the only thing. It wasn't too terribly bad. We're not that far off. I'm going to let that be just for the sake of time. But yeah, you can see everything else matches. 8 matches, this matches, and then this guy right here. All right. So, all right. It's good enough for me. I'll take it. Plus, because I'm rushing, trying to get to this next one. That wasn't too bad. Let me at least change that in my notes. So let me highlight this guy. Only thing was this 2 was supposed to be a 4. And then I factored this, turned that into a 2, and I think that was 8. So, okay, that was fine. But the idea is there. Like if this was in person, I would give that most of full credit. That was close enough. All right, let's hop over to section 1.8. Let me see, I have to go like this. Let me go to the waiting room real quick. Right here, we can do this. Let's hop over to the tablet. And then while that's showing, let me see, we want to get rid of this. And I can put some music on too while I do this. Assignments, let me see the time, okay. Okay. going to make that full screen. Okay. All right, guys, I think we're back. Okay, so that was a little of an adventure. It was good enough for me. I'll take it. All right, let's move on to section 1.8. So that was just a little bit of a demo on the chain rule, right? It takes practice. Just do the best you can. Just keep working. You know, work with your classmates. Make use of the Ask My Instructor. Keep in mind you've already paid for tutors through Morehouse, so you have tutors. Let me hop over here so we can see. So let me go ahead and at least make my header. So this comes from, we can do like week. This is week, 3? This is day 5. Captain's log. This comes from section 1.8, higher order derivatives. Higher order derivatives. Okay. So hopefully, at least with the shortcuts or the rules that we've been talking about, differentiation hasn't been as intimidating as the difference quotient, right? I know that difference quotient usually gives students a hard time, but hopefully with the shortcuts, you know, you can find some excitement in it. So now higher order derivatives, what we're doing in this section, basically higher order derivatives are derivatives of derivatives. Like you're given a function, you can take a derivative, you get an answer. Then can you take the derivative again of that answer? Then like how many times can you do it, right? So that's what we mean by higher order derivatives. That's the gist of it, all right? I think for the sake, okay, we can, let me see. Let's see. For this one might not be too bad. It says find the limit as x approaches 5 from the right. I want to say if we just plug in 5 directly, it's going to give us 0. So coming from the right, it should be defined. Let me think about it. If that's greater than or equal to 0, positive 5, right? Okay. I'm going to say that this limit is 0. So if we were to look at the graph, as x approaches 5 coming from the right, the y value should approach 0. Let me see. Okay. All right. I kind of wanted to get into where we are today. What section is this? 1.8. This one looks like what I would do here. I mean, honestly, it's the quotient rule, low D high minus high D low over low low. I feel inclined to combine this into one rational function first. I just want to click on the view. I'm not going to do this one right now, just for the sake of time. I want to get into, but I want to just see if they combine it into one first. To the first term. So they just took the derivative of the first term. Yeah, you can keep them separate. So they just did high D low minus low D high over low low. They do it for the first one. I'm going to let that be. I think the rest is not too bad. I want to get to something. The first one that says 1.8. Again, this is high D low. Low D high minus high D low over low low. So the bottom times the derivative of the top minus the top times the derivative of the bottom over the bottom squared. That's the quotient rule. Product rule with chain rule. I'm going to let that one be. I kind of want to get into section 1.8. Okay. So this is the second derivative of y with respect to x, right? So instead of dy by dx, this is the second derivative of y with respect to x. Okay. So basically it means take the derivative twice. You take the derivative, you get an answer, take the derivative again. So this is the second derivative, right? Okay. Before I hop over here, I'm going to go ahead and close out this attendance for the day. Let me see. I'm going to say absent, absent, absent. Pretty good turnout. Okay, I'll take it. Let's go like this, like this. Let's take some notes. So this is question number 6. It asks us to find, are you doing that thing again? You are. Okay. Let me reboot this thing. It's like if I move the screen too much or hop around too much, it kind of freezes up. Oh man, did it not save any of my work? can't believe that. Are you serious? Okay, this thing is fun. I was like, come on, you should have said something. I don't think it saved any of that stuff I wrote. Wow, that usually doesn't do that. All right, well, I'm not going to worry about it. Paper. Man, I can't believe it did that. That's so grimy. All right. Now that makes me think of like the joke where Jesus and the devil are in a typing contest. I don't know if you want to hear it, just let me know. Anyway, okay. I'm gonna have to just start over. So we have section. This is week 3. Section. This is day 5. This comes from section 1.8, higher order derivatives. Okay. That's fine. Hopefully it's not too, the handwriting is not too bad. This is question number 6. I know you can't see it. I'm still taking notes. Question number 6 comes from section 1.8. Question number 1. We're asked to find the second derivative. So find the second derivative of y with respect to x. Okay. These twos, these are not exponents. All right. So they're not powers. It just means the second derivative, right? Basically do the derivative twice. Where we have y equals -7 x to the 9 plus 1. Okay. Let me hop over to my notes so you guys can see what I was writing. And looks good. Okay. All right. So basically find the second derivative, right? So the derivative of the derivative. So the first derivative, or dy by dx, the 9 comes down. What is that? 63. So -63x to the power of 8. And then the derivative of a constant, the derivative of a constant is 0, right? So that's the first derivative. What is that saying? Whatever, I'm not going to worry about it. Okay. So then the second derivative, so we want the second derivative of this function with respect to x. So basically the derivative, it's just going to be d by dx of this thing. Okay. So the derivative there, the 8 comes down. Let me see. 8 times 3 is 4, carry the 2, 48, 50, so 504. Negative x to the power 7. So the second derivative is just the derivative of the first derivative, right? That's all. That's the concept behind higher order derivatives. Okay, so we got this -504 x to the power 7. Okay. Let's hop over to Pearson. Let's see, how do we do? We got -504 x to the power 7. God is good. Okay. you gotta have something to keep yourself sane in all of this, because it will drive you crazy if you don't have a balanced life. Like, you gotta balance work and play, pain and pleasure. You gotta balance that stuff. Otherwise it will like send you off the walls, right? So you just gotta, do the best you can. Like, keep in mind, be aware that, like, no matter what happens, there's always a way. Like, you always have a choice. Don't ever feel like you're trapped. You don't have a choice. That's not true. Like, you always have a choice. Usually, if you're talking to somebody and they're not saying what you need to hear, one of my former students, she said, "You're just not talking to the right person." And when I've applied what she said, I was like, "Damn, she's right." So when you're trying to like get things done and you're talking to folk and they're not saying what you need to hear, saying what they need to say, more than likely you're just not talking to the right person. Don't take offense to it. Don't get upset. Just be like, okay, and go find somebody else. Like, but that technique actually applies to so many things other than just getting things done. That's neither here nor there. 1.8. So this is question number 7. I'm taking some notes. I mean, but even with my class, like, just you kind of keep going until you find your place, until you find it. Find the second derivative of v with respect to t. Okay. And we're given that v equals 2t squared plus 5t plus 14. Okay, let's hop over to the tablet. Boom. That looks good. It is like, I mean, the wind is howling. I'm like, man, weather, very peculiar. I don't know if y'all get that movie reference. Anyway, okay, so first let's find dv by dt. So the first derivative. All right, so if we take the derivative, that's going to be 4t plus 5. Remember, the derivative of a constant is 0. Okay. Then the second derivative, now we want the second derivative of v with respect to t. Okay. The derivative of a constant is 0. 4t is just going to be 4. So ultimately, the second derivative in this case should just be 4. Okay. All right. Let's hop over here. Let's put in 4. Enter. I think the chat looks okay. Okay, I'm going to go on to the next question. Second derivative of y. Okay, let's do this one. Now it goes higher. We can go higher than just a second derivative. We got a good amount of time, so I'm just going to kind of keep plugging at these. So this is question number 8. This comes from section 1.8, question number 9. We're asked to find the second derivative of y with respect to x. And we're given that y equals 1 over x to the 4. Okay? No, not that way. I used to go like this and like this. Okay. All right. So first, let's find the first derivative. So dy by dx. That's going to be d by dx. That's going to be the derivative of, I'm going to rewrite this 1 over x to the 4 as x to the minus 4. Okay. So now the exponent comes down. That's going to be negative 4x to the power of negative 5. So then the second derivative of y with respect to x, that's going to be the derivative of the first derivative. So that's going to be d by dx of negative 4x to the negative 5. And that's going to be, the 5 comes down, that's going to become a positive 20x to the negative 6. Okay, hopefully you're able to catch those changes. Yeah, be sure to be eating as best you can. Exercise regularly, routinely, be consistent. It makes a big difference with everything. It helps. That was one of the biggest things I think helped me to get through school. Now with this whole COVID thing, this is different, you know, because it hurts my heart. Like I couldn't imagine not having that college experience of being away from the house and, you know, living on campus. I mean, that was some good times. Like I made sure that I had my fun. I mean, I turned 21 in Africa. I left the country. Like I was like, I'm out of here, and I went to Africa. I don't even know if you could leave the country with this whole thing. I know people that have been leaving the country and like they seem like they're okay, but I know some people that left the country and got stranded for like months on end. So it's just a different time. But I mean, honestly, where there's a will, there's a way. Let me see the time. We still got a good. We go from 6 to 7:15. We got like 20 minutes. Let me go forward. Let me try something else. See what else we got. Let's do this one. This one looks. Actually, can we do a higher? This one looks interesting. I like that one, but I want to find something a little bit more interesting. Just because the second derivative. How come they won't go higher than the second derivative? Now I'm intentionally looking for something that's going higher than the second derivative. None of them? What? Come on. Okay, let's do this one, right? They want the fourth derivative. I was really just trying to get to something that's other than the second derivative. Okay. So, this is question number 17. This comes from section 1.8, number 29, okay? We have this y equals 2x to the 5th, right? We're asked to find the fourth derivative of y with respect to x, all right? Let's hop over to the tablet so the people at home can see. Okay, so basically take the derivative 4 times, right? So then the first derivative, dy by dx, that's going to be what? 10x to the 4. And then the second derivative of y with respect to x, the 4 comes down, that's going to be 40x cubed. The third derivative of y with respect to x, that's supposed to be x. So basically take the derivative again, that's going to be 120x squared. And finally, the fourth derivative of y with respect to x, 240x. I think that's it. Okay. That one wasn't too terribly bad. Okay. Let's hop over to Pearson. Let's do 240x. Let's see what happens. 240x. Awesome sauce. Let me see. We go to 7:15. A little over 5 minutes. Definitely not more than 10 minutes. Okay, let me check my audio. All of that looks good. And the chat looks okay. Okay, I'm going to keep going. I find the fourth derivative of this function. Let's do this one. This one looks kind of interesting. This one. So now that you get higher order derivatives, now let's do something that's a little bit, more challenging. Okay. So this is question number 18. This comes from section 1.8, question 34. We're asked to find the fourth derivative of t of n. Okay. Where t of n is kind of like f of x, but we're just doing t of n. We got this 5n to the negative 1/5 plus 4n to the 7/5. Okay. All right. Let me see. If we get out, we might have this. Either this is going to be the last one, and depending on how smooth this one goes, we might do one more. We might do at most one more other than this one. Let me hop back over to the tablet. Okay. All right. So we're asked to find the fourth derivative, right? So first, let's find t prime of n, the first derivative. So the exponents come down, that's going to become negative n, and then negative 1 over 5 minus 5 over 5 is going to be negative 6 over 5. Plus, if that's a 7 over 5, that's going to become 28 over 5 n. 7 minus 5 is 2 to the power of 2 over 5, okay? So that's all fractions, right? That's the first derivative. Let's do t double prime, or the second derivative. The negative 6 over 5 comes down, so there's going to become a positive 6 over 5, and to the negative 6 over 5 minus 5 over 5 is negative 11 over 5. Plus 2 over 5 times 28 over 5. 40 plus 16 is 56. So that's going to be 56 over 25. That's not a 2. Over 25. And 2 minus 5 is negative 3 over 5. Okay? You can use calculators. I'm just doing my best to do all this in my head, just because I want to. But you can use calculators. That's the second. We got 2 more. The third derivative. So now we're going to say, we can do triple prime. I'm going to do parentheses. This just means the third derivative. Okay? The negative 11 over 5 comes down. That's going to become negative 66 over 25 n to the negative 16 over 5. Okay? Minus, let me see, 150 plus 18, 168. 168 over 125 n to the negative 8 over 5. Okay? One more in the home stretch. Hopefully we can get through this one. I think I have the gall to try one more. I'm going to only do one more after this one. Let's look at the fourth derivative of this function. Yeah, I'm going to have to use a calculator now. Negative 16 over 5. That's going to be 650. I'm not going to do it in my head. Hey Siri, what's 65 times 16?
65 times 16 is 1040.
So 1040 is going to be positive over 125 n to the power of negative 21. I just keep subtracting 1 from that exponent. It's going to be plus. Hey Siri, what's 168 times 8?
168 times 8 is 1344.
I think that one's 625. Hey Siri, what's 125 times 5?
125 times 5 is 625.
And then what is that? Negative 13 over 5. Okay, moment of truth. Oh no, my headphones are losing life. I think I can finish out this example. I think I said I was going to do one more. 10%. Come on, I know it can last. Let's get to the end of class. Let's go with it. Let's see what happens. Okay, we got this result. We're going to hop back to Pearson and cross our fingers. Just for the sake of time, I'm going to put the answer with minimal downtime, 1040 over 125 n to the power of negative 21 over 5, okay, plus 1344 over 625 times n to the power, that's not a power, to the power of negative 13 over 5. Cross our fingers. Darn it. Make sure that you... Let me look at the original. This might have to be the last one. 5. I got my 5. Trying to make sure I have the original question written down properly. 5 n to the negative 1/5. 4 n to the 7 over 5. Okay, that looks good. Let me see, did I type it right? 1040 over 125, negative 21 over 5. That should be plus. Wait a minute. Okay, I think I see an error. Let me hop over to the tablet so I can show you what I'm seeing. Yeah, somehow, yeah, I think it's the signs. Oh, and let's do it like this. Okay, so if I go back and be meticulous, right? So it looks like the original question is fine. I think that's okay, right? So then if we take the first derivative, the exponent comes down, it should be negative. It's gonna be what, 1? Negative 1, that looks good. And then a negative 6 over 5, right? Notice this is negative. This comes down and this is positive. Somehow I think my signs got off. I think I missed a sign. Maybe, maybe not. Maybe, maybe not. Let's keep going. 7 comes down. The 7 over 5 comes down. It's going to be 28 over 5. That looks good. 7 minus 5 is 2, so this looks good. This line, I'm okay with line 2. That one looks good. Let's look at line 3. The negative 6 over 5 comes down, becomes positive. That looks good. 6 minus 5, negative 6 minus 5 is negative 11. That looks good. Oh, 40 plus 16 is 56 over 25, positive. This looks good. 2 minus 5 is negative 3. This looks good. So I feel okay with this line. The negative 11 comes down. That's going to be, up, there it is. 11 times 6 is 66, not 65. All right, let's see if we can recover this. So this is supposed to be 66 over 25. The negative looks good. 56 times 3. Hey Siri, what's 56 times 3?
56 times 3 is 168.
That looks good. 125. That looks good. Negative 3 minus 5 is negative 8. So now with that change of the change, I wrote 5 and it should have been a 6. So now if we do 66 times 16, hey Siri, what's 66 times 16?
66 times 16 is 1056.
1056. So then this changes to 56, okay? Double negative is positive. 125, double negative is positive. Hey Siri, what's 168 times 8?
168 times 8 is 1344.
All right. Hopefully that was it. That instead of writing a 5, we wrote, instead of writing 6, we wrote 5. So it only caused that one change. I'm gonna go with it. All right, this is our second attempt. Okay, so That's how these things go. Like that's why I do unlimited attempts because it's not like you don't get it. It's just you made a mistake somewhere, right? So you got to go back and slow everything down. That's the only thing I think changed. I'm gonna go with it. Oh God, God is good. What's the time? Do I dare try to do another one? We got a solid 10 minutes. We definitely have time to do one more. All right, this will be it. All right, whatever this is, we're gonna make it the last one. Okay, that was fun. And like that's the other thing. Like try to find the fun in it. Like be clear about what you enjoy. Even if you don't enjoy math, find a way to use what you enjoy to do what you got to do. You know what I mean? You know. Anyway, let's go ahead and finish out this last one. Okay. So given this function is in feet and t is in seconds, find the following. So higher order derivatives apply to like a lot of position functions, right? So this is going to tell us like the position of some object based on time. And then the derivative of the position function is going to be the rate of change of an object over time. So that's going to give us the velocity. But then the derivative of the velocity function tells us the acceleration of that item, right? Okay, so given this function, find the velocity, find the acceleration, and then find the velocity and acceleration after 2 seconds. Okay, so let's take some notes. This one shouldn't be too bad. My girlfriend is cooking some food. It smells so good. And she just came off a 3-week fast. I'm like, how did she do this? Like, how? I sat there and watched her. I was like, how did she do this? That's not easy. So I was like, okay, I gotta try. That's neither here nor there. All right, this is question number 19. I be feeling like Goku with the way I laugh sometimes without all the power. Anyway, okay, we got 1.8, question 35. I don't know what that PS stands for, but it comes to section 1.8, question 35. Okay. Maybe word problem, or I don't know. Given S of t equals 2t squared plus 6t. Okay, it says that S of t is in feet, okay, and t is in seconds. What time is it? Okay. Find A, asks for the velocity, v of t. B asks for the acceleration, a of t. And then C asks for velocity and the acceleration when t equals 2. Okay, let's hop over to the tablet. I got the chills, but it's okay. All right, so let's start off with part A. So the velocity is going to be the derivative of your position function, so s prime of t. And that's going to be 4t. That's it, because the derivative of the constant term goes to 0. So that's our velocity function, okay? So then for part B, the acceleration is going to be the derivative of the velocity function, which is going to be the second derivative of your position function. Long story short, that's just going to be 4 in this case. If it's feet, so the units here for velocity, I just want you to be aware, the units here are feet per second, and the units here are going to be feet per second squared. Okay. And in part C, watching the clock, yeah, this will be it. Part C, so the velocity and acceleration after 2 seconds. So then the velocity after 2 seconds is going to be 8 feet per second. Okay. And the acceleration after 2 seconds is going to be just it's no t there, so it's just going to be 4 feet per second squared. Okay. So I think that means the speed increases by 4 every second. I think that's how that goes, right? Okay. All right, so let's hop over to Pearson and let's see how do we do. So the velocity function we got was just 4t. Mm-hmm. What? Oh, 60. How did I just wrote the wrong original function. Oh, I just didn't see it. What was I looking at? Oh, it's 6T and I wrote 64. Okay. Let's back up. So we need to, I'm gonna scrap all my results. I wrote the wrong original. I'm gonna get rid of this stuff. And let me fix the original. It's not 64, it's 6T. And I'm gonna highlight the change, 6T. Let's hop back over to the tablet. It shouldn't take that long to fix this, hopefully. Okay. So with that adjustment, you can see the 6T at the top where we made a mistake. So now when we take the derivative, that's still going to be 4T. Now it's going to be plus 6. Okay. And now the acceleration, the derivative of that, is still going to be 4. Then the velocity after 2 seconds, 4 times 2 is what? 8 plus 6 is 14. And that's going to be feet per second. Okay. Okay. We got this. We got this. And then that's still going to be 4 feet per second squared. Okay. Now let's see if that works. Not back here. So we got 4t plus 6. Okay. The acceleration we got was 4. Okay. After 2 seconds, the velocity was 14 feet per second. 14 feet per second. Okay. And then 4 feet per second squared. 4. This one, feet per second squared. Okay. Okay. Let me check the chat. Let me kind of reset all my stuff and do some closing remarks. Not too terribly bad. Okay. So it is a little bit a good amount of work. We can anticipate exam 1 to be available next Wednesday, not this upcoming Wednesday, but a week from this Wednesday. Exam 1 should be over, I think it was like R4, R5, Chapter 1 and Chapter 2. Once we get past Chapter 2, the pace is going to slow down. Like, I'm not going to be doing 2 sections a day. I know that's a little intense. Once you have that shortcut, just use the shortcut. Like, I know that limit definition of the difference quotient can be very time consuming. If you want to practice it, it is a good idea to practice that. But, just be cognizant or be savvy with your time. Like, maybe just go ahead and finish it and then go back, and practice the difference quotient. But, you want to try to be as savvy with your time as you can, but still be accurate. I would just move through things as quickly as possible. But yeah, once we get past Chapter 2, it'll slow down and we'll reduce the rhythm to 1 section per day. Okay. I know there was one student that had a question. I don't know if he's still here or not, but if he doesn't stop me in the next few seconds, it'll be. But on that note, we're going to end the session here. And from one beautiful mind to another, enjoy the rest of your day, guys. All right, take care. Peace.